That's fine. Okay, so we're at part 13 of the AWS series. Can you imagine we're on part 13? That's amazing. And today we're gonna talk about AWS Aurora, which is Amazon's database. So this is for Amazon. Okay, so tables of content. We're gonna talk about a brief introduction. As always, I think the tables of content are like every other one we have made. So we're gonna talk about introduction, key features, component, performance, pricing, and use cases. But before I start in Aurora, I just wanna make a quick recap of the RDS because of course Aurora is one of RDS services, and I wanna make like a very quick recap on RDS to just like sum everything up, especially that I was not the host of that session. I just wanna like sum everything up and recall what we have made. Okay, so first thing, we have two type of databases. We have more than two type, but let's just say we have two types. So we have something that's called a relational database. So relational database, or in Arabic, database ذات علاقة. And we have what's called a non-relational database. So I'm just gonna add like here, non-relational database. Okay, what's the difference between the two of them? Where in a very easy way, we can say that a relational database consists of rows and columns, and a non-relational database doesn't. Okay, that's like very briefly the difference between them. So typically the first column is the primary key, and we're gonna talk about it if we will do our database week. So typically the first one is a primary key, which is an identifier or an ID that we can use. So ID. Actually, my drawing is getting better, I'm not gonna lie. And then the rows are gonna be data. So those are data. Yeah, I just like fucked everything up, sorry. Okay, so everything else is data. So all the rows, so data 1, data 2, data 3, whatever. This is a relational database. It's more of a structured way. We can say it's structured. So database ذو علاقة بالضبط لأنها ذو علاقات، فهي عبارة عن something ممنهج و structured جاي مبني بناء. So structured. Okay. So and what we use to write databases in, or what we call a language that we write database in, is called a SQL language. So structured query language. Let me write that. So structured query language, which is in between brackets SQL. Okay, so as we said, quick recap, sorry. So a relational database is made out of rows and columns. We have a primary key. We have also something else. We have a lot of things. The primary key is used for identifications or ID, and the rows are data. So it is a structured way to store data. And to write the relational databases, we use something what's called a structured query language, or SQL or SQL, whatever, that doesn't matter how we pronounce it for now. And a relational database contains of AWS RDS, AWS Aurora, and that's it. Yeah, maybe Oracle database, MariaDB, Postgres, MySQL. There's a lot of what is called a database engine. Okay. So no, I don't want the X to go. Okay, so non-relational database system is kind of the opposite. So it contains of whatever, maybe just lines, and you can consider JSON script as. So let me take this as copied. So it's non-structured. It's literally the opposite. So non structured, and the language is, it's not SQL, it's what's called NoSQL. So NoSQL language. It can be like, I think, JSON. So JSON, any kind of stuff. It can be graphs like Neptune. So if we said what AWS services are not relational, we can say DynamoDB. Sorry. We can say DocumentDB, which is compatible with MongoDB. MemoryDB, Neptune. There's a lot actually. I think the rest, Neptune, Redshift. I don't consider Redshift as a database. I think it's a data warehouse. So let's say Neptune Quantum Ledger, maybe, or time. What's it called? Time series? No, not Kinesis. It's in the database. Check it out. So typically those are the things. So DynamoDB, DocumentDB, MemoriaDB, and Neptune. Neptune is a GraphSQL in-memory database, and Document is compatible with MongoDB, and DynamoDB writes JSON scripts. Okay. So this is the main difference between these two. I'm gonna give, I think, after we finish the camps, the hands-on labs of AWS and everything in AWS, I think I'm gonna go to a database series because I think it's very important to learn database. So from 16 of September till the end of September, I'm gonna give database. Yeah. Okay. So we've talked about relational databases, and if we went to RDS, which is a managed relational database system from AWS, quick recap, we can see that actually RDS supports multiple engines, which are, so if we want to create a database, we can see how many engines we have. So we have Aurora, which is MySQL compatible, and Postgres compatible. So we can say that Aurora is one of RDS services, but those are like related to Amazon. These are Amazon engines that are compatible with MySQL and Postgres. We have MySQL, which is the dolphin right here, and this is the seal, so MariaDB. We have also Postgres. Personally, I love Postgres, and they have added the IBM like recently. It wasn't on my exam, but it was added recently. So also we have Microsoft SQL Server and Oracle. Those are the things we have. We can choose Aurora, which are going to be our topic for today. We also talked about, where is it? I saw it. It was like RDS custom. I think if I put Postgres, I'm going to have it, maybe. I just saw, I don't know what I have clicked, but it showed me that I can do RDS custom. We also talked about RDS custom, which is the ability to make your own customized database for legacy or old applications. So let's write this down again. So RDS custom is for legacy or old application that need special configuration. Also, we've talked about what we call read replicas. I told you guys, I just want to give a quick recap of the RDS because, as we said, that Aurora is one of RDS services. So I want you to understand the basics of RDS really, really good. So we have this thing that is called a read replica, or what's called a master and slave replica, or endpoints, let's say. So a master is what is, or it is the main server. So this is master for main, which is السيرفر الرئيسي خلينا نحكي, the main character. And then out of it comes what's called a slave server. So these may be read replicas. These may be just replicas that have copies of the master one, or this is what a customer is actually access. They don't access. Maybe they don't access the master. Maybe they do. It's based on a business case. Okay. So read replicas is kind of the same. It's not 100% the same. It's kind of the same, let's say. So we have one write database. Change color. I'm feeling purple, so let's go with purple. Okay. And then out of it is what we call a read replica, or just have a read operation. Why do we need read and write database? So of course, write is for modification. So let me write this down. Of course, you want to like write, add, so modification. So maybe like login page, you need it to be write database. And then read replicas is only for reading, maybe like a weather app. So you just wanna like read the weather. So if I kind of open the app weather, so Arabia weather, let me show you, which is called طقس العرب, of course. This is the weather forecast. So as you see here, I'm not entering any kind of data. I'm just seeing it. So this is what's called a read operation, and I'm getting them from their databases. I'm just reading it. So now if I want to log in, as you see here, I'm going to enter something and I'm going to modify their database. So then I'm going to have what's called a write permission. So these are the different, of course, read replicas make stuff easier because you only need to read data, so you don't really need to have the access to write, and it gives you the ability to separate write and read. Wait, but I said that wrong. So read and write, so you can separate them. It's much more efficient. It also, you can like, I think you have the ability, if the right one or the main one fails, you can fail over to one of the read replicas and make them a write database. So also in the, So also in the let me go back. So also in the master database, if or if the master database fails, it can fail over to one of the slaves and makes it a master database. So this is the power of cloud. If you have this on premise, I don't think it's very easy to make it to fail over to another server and make it a master server. In AWS, it only takes like 2 minutes. Come on, guys. It's very good for businesses, I guess. So again, we've talked about another recap. We've talked about what's called a single point of failure and a failover. So a single point of failure, let's see here, we have a server and the server failed. So now the system is down. So this is a single point of failure. So one server, and this server fails. So we have what's called a single point of failure. To solve this problem, this is in Solutions Architect or in basic IT, so IT 101. To solve this kind of problem, what you can do is make let's remove the S for server, and I remove the whole server, so we have now a failover. I'm just looking. So here we have a master. So to solve the single point of failure, we're just gonna add a slave server. So every time this master or this main server fails, it can fail over or go to another point or endpoint. Okay. Again, guys, quick recap. I think that's it for our quick recap. That was a very wrong. That was a very, very long recap. I don't know what's wrong with me. I can't even talk correctly. It's been like 3 days, guys. لوز دي ما نزلوا لسه ما. Okay, guys. So as we said, we're going to give a brief introduction, the tables of content like always, key features, components, performance, pricing, and some case cases. Okay, so I think we have talked a little bit about the introduction. So it's a fully managed relational database that is provided by Amazon. We've talked about this. It's also highly designed to be high performant, reliable, and scalable, of course, because it's managed by AWS. I think there is like, it's Aurora that is MySQL compatible. I think it's better and much cheaper. So I think it's 1 times 5 better than MySQL. And 0.3 better than Postgres. Postgres SQ. Wait, let me remove this and this. Yeah. So this is L and PostgreSQL. And it's 1/8 cheaper. So you get better and much more performance for a cheaper price. So جايز عشان أعيده بالعربي هو أحسن 5 مرات من ماي سيكوال. فإذا أخذنا أورورا ماي سيكوال which is compatible هو أحسن من ماي سيكوال العادي which is هي down here 5 times better and 3 times better than another engine which is called Postgres which is right here the elephant which is my favorite database and you get it بثمن السعر فأنت راح تاخده واحد أو ثمن أرخص. So what do you need better than this? You get high performance, you get better performance, better reliability, better scalability, and for a cheap price. So it's a good deal for me, I guess. Okay, so a few key features we have. It's of course, as we said, high performance, it's highly available and durable. It has great security, it's compatible, and it's a global database. Of course, we're going to talk about them as you can see here. So high performance, of course, we've talked about latency. So again, a quick recap, what is latency? So latency is basically, let me go to elements. I think I have my server here, so server. Where is my server? The pink one, yeah, this is great. And then I have a user. And there's my user. Okay, so latency is the time between a user and that's the worst error. So latency is the time between the response of a server and the request of the user. Of course, the lower the latency, the better. So lower latency, the better, and the higher the latency, the worse. Like, can you imagine if I want to click here slideshow and it's gonna take like 5 minutes to open the slideshow portrait? I'm gonna like, okay, I don't like Google Slides. I'm gonna use another thing. So it's low latency, as we said. Of course, it provides here, you see, 5 times better performance and 3 times better performance than Postgres. And you can see here that Aurora can automatically scale up to. That's really huge. Like 64 terabytes, not gigabytes, it's terabytes without downtime. So it can scale up to more, yani less like more than 50 terabytes and with no downtime. So it's not gonna fail. And up to 50 low latency read replicas. So we've talked about read replicas and we've talked about downtime or a single point of failure. Okay. So highly available. So it's a fault tolerant storage. Of course, it's replicated 6 ways across 3 AZs. So if we have, let's say, if we have, here's AZ1, so A1, and we have A2, and we have A3, and here's our database. So we know that our database is replicated 6 times across 3 AZs, which is awesome. So let's say if AZ1 all fails and AZ2 all fails, we still have AZ3. Can you imagine the durability and availability of Aurora, which is awesome? We've talked about failovers. So we can have automatic failovers. I said like 2 minutes. Apparently here it says a few seconds. So I think that's even much better. And it has automated backups, which is a continuous backup. So we also talked about something what's called automated. So automated, no human is there. So everything is handled via machines or scheduled works. بالعربي automated يعني فيش تدخل إنساني فقط كله ماشي على تدخل آلات. Of course, encryption data is encrypted at rest and in transit. So if you remember this, so if the data is moving between a user and a server, this is called, so if data is moving between, so if data is moving between a server and a client, this is called data in transit. Of course, transit or transportation, let's say. So if data is moving, it's called data in transit, and if data is not moving, it's just in the server, it's called data at rest. So data at rest. So if the data is only here at this server, it's called data at rest. So if data is here, data at rest. If data is moving between the user and the server, this is called data in transit. Of course, there is encryption for both of states, so at rest and in transit, and we're gonna talk about VPC integration and all of these stuff. And IAM, we've talked about it, AWS Identity and Access Management, and we also talked about fine-grained access control. Okay, so compatibility is MySQL and Postgres compatible. We've talked about this. Don't really care about the versions of the engines. And migrations, we can easily migrate MySQL using what's called a DMS, or a database migration service. So actually, if you type DMS, it's a service, it's a standalone service that is used for migration services. So we can use that with Aurora. Okay, so global database, we have something what's called a global write operation. So if you have multiple databases in multiple regions, you can write in one server and it's gonna distribute to across servers. And you can have it multi-region, and you can have read replicas. It's like massive, so it's global. It's globally distributed, let's say. So till now, before we go with components, does anyone have any kind of question? Like, it's very huge, I know. It's very amazing. We're gonna see something that's called clusters. A few stuff. Okay, so I think if no one's asking any kind of questions, I think that everything is good. Okay. So we have three components. So we have cluster volume. So we have a cluster volume. It's basically like a bunch of servers. So these are a cluster. Okay. So here you can see that a single virtual volume that uses SSD is made up of multiple data copies across different AZs. So literally the drawing that we draw here, this is called a cluster. Okay. So database instance, we have the primary and the replica. We also talked about this right here. So we have a master or primary, it's calling it primary, and we have here the replicas. So we also talked about these. As you can see here, also we've talked about handles all the write operation and can also do read operations. And it only handles read-only queries and serves failover targets for high availability. So endpoints, we have something what's called a cluster endpoint and a reader endpoint. This is a bit more advanced, but I'm gonna say it anyways. So a cluster endpoint is literally that distribute connections among available instances in the cluster. So let's say we have like multiple instances. So this is an endpoint that these instances are connecting with each other, and a reader endpoint. So it's directed for read only to replica instances. So let me draw it like really quick. So if we have primary 2 in different zone, let's say. So this is a cluster endpoint. And if we have what's called a primary, that's R. So primary, That's D. Okay. And we have another slaves or read replicas. Let me do an R. So this is called reader's endpoint. So this reader endpoint. Okay. So performance. Let's go and check. Like, okay, I'm choosing like my Aurora MySQL database. And we can see here, we can choose a few templates on settings. So you can see here managed and all this kind of stuff. So yeah, this is what I want to see, that you have something that's called a cluster. So yeah, so here you can see that create an Aurora replica or reader nodes in different AZs recommended for scaled availability. And this is, you can here like choose that to not replicate. Of course, it's going to cost you to replicate. So you're going to pay more money for replication, but you're going to have better performance. So we have something what's called replicas, which is it can create up to 15 replicas in addition to the primary one. We can have something what's called a parallel query. So parallel query is literally, we've talked about parallelism. So if we have a query, so here we have, or let me just enter Q. Oh. So if we have Q, which is a query, it's gonna be parallel like this. And it's gonna enter like a few stuff and a few mechanisms that is advanced. I'm not gonna say it now. And then it's gonna come back to result, let's say. So result. This is parallel query. And serverless, we talked about serverless. Of course, if we choose that is AWS managed, so as you can see here, like this is credentials, but you can actually choose to be AWS managed. You're not gonna manage anything. It's gonna like manage or AWS are gonna manage the infrastructure. So let's see. If we take Aurora and we take EC2 and install on EC2 database. So easily, which is easier, which one is easier? Of course, this one is the easier to manage. And this is, you have more control over the infrastructure and it's harder to manage. So you have to control like everything. So لنفترض بالعربي، لنفترض انه انا عندي بس اورورا، بس بدخل عليها كل شيء مانجد عني وانا ما بتحكم في شيء. لنفترض عندي virtual machine زي EC2 instance، بعمل عليها upload I have to manage everything from scratch. So data configuration, infrastructure, and everything. Of course, based on the business case, some things are better than things. You can't just say, oh, okay, of course, for me, the Aurora one is much easier, but maybe it's not compliant. So these are chosen based on the business case. So pricing, we have on demand. So you're going to be charged by the hours that are used, pay as you go. Reserved, we can reserve it by committing to a 1 or 3 year term and up to 65%. And serverless, it's based on how many, it's like on demand, but it automatically shuts and starts, sorry guys, so it automatically starts and shuts down or scale the instances. Of course, you're going to pay for that all. So why do we need to use databases? I think it's kind of obvious. Like I put this slide just for confirmation. So you can use it for web and mobile application. You can use it for SaaS application. Of course, a SaaS application is like Google Slides. The one I'm using right here is like Canva. It's something ready to use. Emails, let's say. Emails do run on cloud. So web mobiles, SaaS applications, enterprise applications, and disaster recovery. Of course, there's a lot of use cases, like basic, it's a database. So yeah, like databases, I think is one of the easiest thing to learn. It's quite literally English. Okay, so I think we have finished today's lecture. It was a very quick lecture, I have said. Our lectures were going to be very quick from now on, except AWS S3 buckets. So yeah, let me stop the recording, guys. Stop record.